Hey, it's Dr. J. Just a real quick update on 7.4, a couple loose ends. In reviewing the video and getting a lot of questions from students about finding all the solutions and multiples of 2 pi or 2k pi. The multiples are k times 2 pi. I realized that all the examples that I gave had multiples of 2 pi, but there are other possibilities depending on what the value is or which trig function you're talking about. So, for example, if I said, sine x is equal to 0, and I want all the solutions, well, when you look at your unit circle, sine x is equal to 0 here, 1, 0, and here, negative 1, 0. Remember, sine is the y coordinate. So that's not a multiple of 2 pi, that's a multiple of pi. So your angle is 0 degrees or 0 radians plus any multiple of pi. So the solution would be 0 plus k pi. And if you start with 0 plus k pi, that includes the point that's at pi. That would be included as the first multiple. If k was equal to 1, well, then that would give you this multiple. And k is any integer. So when k is positive, you're going around counterclockwise. If k was negative, then it would be going around clockwise. So this value here would be negative pi if you're going around clockwise. All right, so keep that in mind. It's a special case because it's equal to 0. And the same thing happens with cosine as well. Basically the same idea. Cosine of x is equal to 0. That would be here and here. 0, 1, and 0, negative 1. Now cosine is the x coordinate. So again, you have multiples of pi, not 2 pi, multiples of pi. So you'll start at x equals pi over 2 this time. Usually give me the smallest positive solution. It's what we call the initial solution. That's the seed. And then we're going to go around, if you go around 180 degrees, then you add k pi. And that would be going around counterclockwise. If you go around clockwise, similar idea. It's the same idea. If k is any integer. So your solution here would be pi over 2 plus k pi. K is the element of z. It means that k is an integer. Fancy, we say k is an element of z. All right, so those are special cases for sine and cosine. All right, if the value is equal to 0 only, those are the only ones in which you add multiples of pi. And there is a third special case. I don't think it showed up in the homework, so I don't think this one's going to cause too many problems in your homework, but you are going to take calculus next year, and I can't let you go without telling you. A tangent is always a multiple of pi, even if it's not 0, So no matter what this value is, this value could be any real number. I just picked 1 because I'm trying to make this a short loose ends video. If I make it too complicated, it won't be very short. But now this is not based on the value. For tangent, no matter what the value is, it's a multiple of k pi plus whatever you actually get for your solution. So tangent is 1 at 45 degrees, right? Pi over 4. Yeah. So the hypotenuse is 1. The tangent is the ratio of the sine to the cosine. Yeah, so tangent is sine x divided by cosine x. That's my quick way of saying the ratio. So the ratio here is 1. Yeah, root 2 over 2, root 2 over 2. That's 1. I better give you the answer. So the answer will be pi over 4 plus k pi, where k is an integer. So again, for tangent, the period of tangent is always pi. In other words, it completes an entire cycle in half the time, in 1 pi, not 2 pi. So if you go around 180 degrees, you're down here, tan x is still 1. Tan x is 1 down here in quadrant 3. And then it's 1 again, and it just every multiple of pi, it's back to being 1. Okay. In fact, tangent hits every real number infinitely many times, every multiple of pi. Okay, I know that's kind of late, but many of you are still working on your homework for 7.4, so hopefully that'll help when you get to the end. Stay tuned for more of Chapter 8 coming later. So.